In 2008, panic spread as newspapers warned of a machine capable of creating black holes. Some feared the experiment would swallow Earth from the inside. Conspiracy theories exploded online, suggesting scientists were about to trigger an irreversible catastrophe. Lawsuits were filed to halt the activation, with critics describing hypothetical scenarios like vacuum decay that could instantly unmake the cosmos. The focus of this terror was a massive facility buried 100 meters beneath the border of France and Switzerland, the CERN Large Hadron Collider. While the machinery was complex, the anxiety was simple. To many, it felt like humanity was risking the destruction of reality just to satisfy a hunger for knowledge. But the scientists weren't trying to destroy the world. They were trying to understand why it's made of solid matter in the first place. For decades, physicists relied on the Standard Model to describe the universe. It worked remarkably well, except for one problem. Math suggested particles should have no mass. They'd move like light, meaning humans could never form. To solve this, researchers proposed an invisible field filling the cosmos. Particles experience drag passing through, like moving through cosmic syrup, granting them mass. The Higgs field. Proving this theory required evidence of a specific particle connected to the field, the Higgs boson. Finding it became the most significant hunt in modern physics, but it required recreating the intense energy present just moments after the Big Bang. To find that particle, CERN built the largest machine ever constructed, a 27-kilometer ring of superconducting magnets buried deep underground. To operate, these magnets must be chilled to temperatures colder than outer space. It is a system of extreme vacuums and building-sized detectors, consuming as much electricity as a small city. The machine works by accelerating protons to near light speed and smashing them together. These collisions generate bursts of energy that allow particles that don't exist in our daily reality to briefly appear. It was this process that triggered the black hole panic. But scientists pointed to a piece of evidence that had been hiding in plain sight for billions of years. Cosmic rays from space strike Earth's atmosphere every day with far more energy than anything produced inside the collider. If these types of collisions actually created planet-destroying black holes, Earth, the Sun, and every star we see would have vanished long ago. The laws of physics showed the risk of apocalypse was essentially zero. However, the public reaction revealed that our tools have reached a scale where they sound more like science fiction weapons than scientific instruments. The machine did face a disaster, though it wasn't the one people feared. Days after activation in 2008, a faulty connection caused a massive helium leak. It damaged the magnets and shut down the project for over a year of repairs. Once restarted, the collider began producing mountains of data. Scientists searched through these patterns for years, looking for a tiny statistical signal that would prove the Higgs theory correct. In 2012, they found it. Researchers announced they had discovered evidence consistent with the Higgs boson, the particle nicknamed the God particle. The discovery validated decades of theoretical work. It provided the component required to explain how matter takes physical form, providing a level of detail the Standard Model had previously lacked. But confirming the Higgs boson also highlighted how much of the universe remains a total mystery. Scientists had finished the Standard Model, only to be reminded that the model only describes a fraction of reality. This diagram shows the scale of our ignorance. Everything we measure with the Standard Model is a tiny sliver. The rest is dark matter and dark energy. Since 2012, the collider has remained stubbornly quiet, and nature has not revealed anything else. This silence suggests that reality is far stranger than physicists imagined. It's possible we have reached the temporary limit of what our current technology can observe. The collider has become a symbol of a modern tension. While previous generations saw science mainly as progress, today's massive projects often inspire a mix of awe and existential dread. It proved that the universe is governed by invisible fields and particles that vanish in an instant, a reality that completely defies our common sense. Yet the machine also represents a massive human achievement. Over 100 countries coordinated their best minds to solve impossible engineering puzzles, demonstrating we can work across borders to pursue a shared goal. We built a machine powerful enough to touch the conditions of creation itself, risking fear and failure along the way. We did it for one ancient, persistent reason: just to ask why anything exists at all.